All right, we're going to discuss problem 6. So the problem is that you're now a DJ and you're playing Shake It Off and you want to switch to Wireless Dreams. And the transitions that you can make, so you can go from one song to another song, and those tempos should not differ by more than 10 beats per minute. And you want to find the fastest way to transition from Shake It Off to Wireless Dreams. So the first question is kind of asking us how we can construct a graph that can help us solve this problem. So let's see, our problem is asking us to move from Shake It Off to Wireless Dreams. So we need to think of what the vertices are going to be, what the edges are going to be, and how we can use this graph to actually find the shortest way to go from Shake It Off to Wireless Dreams. So what we can do initially is set the vertices to be the songs, right? So if we have like say 5 songs, we make 5 nodes and put the song name in each one of these nodes. And now we need to find out the fastest way to get from Shake It Off to Wildest Dreams. So there's one problem, right? How do we know if 2 songs tempos differ by more than 10 BPM? We don't know anything about the BPM of the songs yet. So what we're going to do is store more information in these nodes, which is we're going to store the BPM of each songs. So you can see that this one's 150, Wireless Dreams 120. Right. Now, next, let's think about our edges. So what edges can we have that can help us get from Shake It Off to Wildest Dreams really quick, right? So we can think of having edges which have valid song transitions. So for example, say from Shake It Off to Lover, which would have a difference of 20 BPM, and that would not be a valid transition. However, from Shake It Off to Love Song, that would be a valid transition because the difference between both of their BPMs is 10. The next question in this graph would be, do you want this to be directed or undirected, right? Uh, Probably directed, right? Because we don't want to move from Love Song to Shake It Off. We don't want to go to a higher BPM because our aim is to go from this higher BPM song to this lower BPM song. So we want this to be directed and in the direction of a lower BPM, right? Um, so the next question is, how will we transition to this Wildest Dreams quickly as possible? We now created this graph that represents our valid transitions. Now we need to think about what algorithm we can run or which songs we can choose to move to Wildest Dreams as quickly as possible. Uh, One thing that we have noticed here is there's more information that we haven't used. So we know the length of the song and we haven't used it yet. So let's think about how we can use that. So we can essentially encode the length of the song as in the edge. So we could say that the edge length from Shake It Off to Love Song is 237 seconds, which kind of gives us more information about uh, how long it's going to take to go from this to this. So imagine if we had another song with 140 BPM and that was like say 100 seconds. So you would know that going there is faster than going here, right? And now that we have this, what algorithm can we make use of edge weights to give us the shortest path? Dijkstra's. So now our graph model has everything we need to find the shortest path between Shake It Off and Wild Streams. So let's go ahead and create our entire graph. So we need to make an algorithm. This question is asking us to give us an algorithm that can produce the entire graph. So we just talked about one edge right here. So we need to write some kind of code that can give us all possible edges and all possible transitions, right? So to do this, you'll probably have to like consider each pair of edges, right? So you're considering if this a valid transition, it's not because it's 150 and 150, which is you can't transition. You don't want to transition to the same BPM. You want to transition to something lower. Is this valid? Although this is lower, it's much lower. We can't have it being less than 10, less than more than 10. So the difference between both of these BPMs is 20. So that's not valid again. Again, this one's not valid for the same reason. So we do this for every pair in the graph. We check every pair of vertices and add an edge if it's valid. And remember that our definition of valid here is that the BPM does not differ by more than 10. So this one's valid and all of these are not valid. Now we're considering all pairs with this node, which one's valid. And we see that moving from here to here is valid and none of these others are valid. Now we're doing the same with this node and we see that this one's valid. Doing the same with the last node, we see that none of them are valid transitions. So this is how our final graph would look like. So thinking about the code, we're essentially just looping over each pair of node. So we have two for each loops, and then we spoke about something which is a valid transition. So a valid transition is when the S2 BPM is less than the S1 BPM and the difference is less than 10. So that's when we add our edge. So this part, this inner loop essentially is doing what we did over here where we were questioning if this is valid. So if are these valid is essentially being answered by this inner if loop. And the two for each loop outside are just iterating through each pair of nodes. So as long as our data structure has an efficient iterator, our algorithm is going to run in O of S square times, where S is the number of songs that we have or the number of nodes that we have in our graph. All right. So now to think about what's the fastest way, what transition do I need to do to move from here to here, and how do we do it in the quickest possible way, right? What's one algorithm that we can run? It's Dijkstra's, right? Uh, So when the algorithm finishes, you can use like back pointers from Wildest Dreams and reverse the order to find the songs to play. So once Dijkstra is finished, it's going to find the shortest path between Shake It Off and Wildest Dreams. Then you can just kind of follow this path back and see which songs to play to reach Wildest Dreams. The final question that this problem is asking is the runtime. So how long does it take to construct our graph? We discussed this previously already. It's O of S square. Um, Running Dijkstra's on a graph is E log S plus S log S. And this is just the runtime of Dijkstra's. So the total runtime would just be the addition of both of these. And then we can notice that S square dominates S log S. And that's why we can just like simplify this. We can drop this term because this is getting dominated by S squared. So the final runtime is going to be O of S squared plus E log S.